Imagine boarding a spacecraft knowing that at a certain point in the void, Earth can never bring you home. The view is beautiful. The silence is terrifying. Because there is a brutal truth hidden inside every mission. There is a line you cross where rescue becomes impossible. It starts with a flicker, a warning light, a tiny leak, a number that shouldn't be moving. In any other emergency, you do what humans have always done. You call for help. And at first, the response feels like a lifeline, because Earth answers. But that comfort is a trap. There is a point where mission control can still hear you. They can still watch you. They can still tell you exactly what to do. And they will be completely powerless to save you. Not because they don't care. Not because the engineers aren't smart enough. But because at this distance, the physics of space never allow help to arrive in time. Distance doesn't just separate you from home, it destroys the very idea of rescue. Tonight, I want to show you the exact moment Earth stops being a safety net and becomes a distant audience. Once you see it, you will never look at mission control the same way again. We love to imagine space like an ocean, a ship sailing out, with a radio and a crew supported by experts back home. But oceans still allow real-time decisions. Space does not. The moon is 384,400 kilometers away. It takes about 1.25 light seconds for a signal to travel. So if something goes wrong, a message reaches Earth in a second, and an answer returns in another second. It's a delay, but it's still human. You can still have a conversation. Now go farther. Mars is at a staggering average distance of 225 million kilometers. Mars isn't far in distance the way a city is far. Mars is far in time. Depending on where the planets are in their orbits, whether they are 55 million or 400 million kilometers apart, a radio signal takes anywhere from 4 minutes to 24 minutes to travel just one way. That means a single question and a single answer can take 48 minutes. And that's only the signal. It doesn't include the hours it takes for engineers to diagnose the problem, to run simulations, to argue, to decide. In a real emergency, you are never having a conversation with Earth. You are sending messages into the past and hoping the future can still use them. If your oxygen is dropping, if a fire is spreading, if a pressure leak is widening, an answer that arrives 48 minutes later might be correct, but it is also meaningless because you needed it when the problem was small. In deep space, the crisis has always moved faster than the help. This is the first irreversible crack in the safety net. You can still talk to Earth across 225 million kilometers, but Earth can no longer respond in time. Here's the brutal reality about emergencies that most people never realize. Most disasters don't begin as disasters. They begin as tiny, almost invisible mistakes that grow. A small leak that becomes a fast leak. A temperature drift that becomes a total system failure. A sensor glitch that leads to a wrong maneuver. On Earth, you survive because humans and machines can react in milliseconds. In deep space, every decision you make is poisoned by physics. Picture this. A warning light flickers. Your life support system is showing a 3% instability. You send the data to Earth across 225 million kilometers. Earth receives it 24 minutes later. Then engineers must analyze it. They compare it with known failures. They argue. They build a plan. They send instructions back. And those instructions travel for another 24 minutes. In total, that's a 48-minute delay. So what was once a system running slightly outside its limits has had nearly an hour to get worse. In a crisis, An hour is an eternity. By the time Earth's solution arrives, the problem it was meant to fix no longer exists. It has evolved into something much more devastating. That is the trap. The farther you go, the more Earth becomes a helpless consultant instead of a rescuer. And the crew becomes something terrifying. The crew becomes the absolute and final authority, not because they want to be, but because they have to be. In the deep void, you are always alone with your mistakes. Once that 48-minute gap opens up, the safety net isn't just frayed, it is completely gone. Even with a 48-minute communication delay, you might think, if it's truly catastrophic, they'll send help. That idea comes from living on a planet where help can always physically reach you. But in deep space, that idea is a deadly illusion. In low Earth orbit, rescue is difficult, but possible. The International Space Station is only 400 kilometers up. If a life-threatening emergency happens, rescue plans are already in place. Return vehicles exist. Emergency procedures are ready. Even in the middle of a disaster, Earth is right there. Now compare that to the deep void. A rescue ship is not a helicopter. It's not even an ambulance. A rescue ship is a second interplanetary mission. Think about the math. To launch a rescue, you need a rocket fueled and ready. You need a vehicle prepared. You need a trained crew. And most importantly, you need a launch window. You can't just go to Mars, because orbital geometry only allows a launch every 26 months. If you miss that window, a rescue is mathematically impossible. Even if the planets align, the travel time is not days. It is 6 to 9 months each way across a minimum of 55 million kilometers. So if you have a life-threatening emergency out there, the rescue doesn't arrive late. It arrives after the story is already over. The cruelest part of this reality is the isolation. Earth can still see you. Earth can still hear you. Earth can even calculate the exact second your oxygen will run out. But Earth cannot reach you. Not quickly, not realistically, not in time for a human body to survive. Beyond the no rescue line, you aren't just far from home. You are out of reach forever. This is where the topic stops being about rockets and becomes about fragile biology. On Earth, the most important factor in survival is not medicine. It is time. Minutes decide whether you live or die. A severe infection can turn deadly in hours. Internal bleeding doesn't wait for launch windows. A ruptured appendix doesn't care about orbital mechanics. These are problems that are routine on Earth, but they are existential in deep space. Think about the numbers. The International Space Station is only 400 kilometers away. If an astronaut has a heart attack or a stroke, they can be in a hospital in less than 3 hours. But on a mission to Mars, you are at least 55 million kilometers away. The nearest hospital is not hours away. It is 6 to 9 months away. If you have a life-threatening emergency out there, the time to care becomes the time to death. Even if you had a brilliant doctor on Earth, even if you had the perfect diagnosis, even if you had step-by-step instructions, you still have one final brutal barrier. You have to do the procedure yourself, in a small, vibrating module, with limited tools, with a crew that is already exhausted and stressed. There is no intensive care unit, no emergency room, no backup team. There is only you and the ship, and the countdown. At this distance, the truth becomes unavoidable. In space, you don't just travel away from your home. You travel away from Earth's ability to keep you alive. Once you cross that line, a simple medical hiccup is no longer a problem. It is a permanent end. While you are trapped in that 48-minute communication delay, there are threats you can't negotiate with. Threats that are silent, invisible, and constant. The first is radiation. On Earth, you live inside a shield, the magnetic field, and the atmosphere. They block 99.9% of the high-energy particles that would otherwise destroy your DNA. In deep space, that shield is gone. The dose of radiation an astronaut receives on a Mars mission is 870 to 1,200 millisieverts. That is 700 times more than on Earth. It is the equivalent of getting 632 CT scans in just 2 to 3 years. It doesn't feel dramatic in the moment. It feels like nothing. And that is exactly why it's terrifying. Because it accumulates. Day after day, month after month. It is a slow, irreversible clock ticking down inside your cells. Then there's power. Near Earth, sunlight is abundant. Solar panels are reliable. But as you travel toward Mars, the sunlight weakens. For every kilometer you move away, the energy you can harvest drops. Systems become less forgiving. A failure that could be repaired near Earth becomes permanent far away because you simply don't have the energy to recover. Then there's the environment itself. Micrometeoroids, tiny particles moving at 30,000 kilometers per hour. They move fast enough to punch through titanium. Most of the time, nothing happens. But in deep space, you don't need most of the time. You only need once. And above all, there's the psychological weight. Not the cliché version. Not astronauts feel lonely. The real weight is knowing this. If something goes wrong, the universe will never pause. Earth will never arrive. The laws of physics will never bend. You're operating at the absolute edge of human support. And every day beyond that edge, your margin for error becomes zero. People always want a number, a line in kilometers, a distance where the rules suddenly change. But the no rescue line isn't a single coordinate on a map. It is a condition. It happens the moment your survival depends only on what is already inside the hull of your ship. Your people, your spare parts, your medicine, your oxygen. Beyond that point, Earth is no longer a base of operations. It is a spectator. Because once you are deep enough into that 225 million kilometer void, Earth can only do 3 things. Earth can listen, Earth can calculate, and Earth can hope. But Earth can never intervene. That is the shift. That is the moment you stop being on a mission supported by the planet and become something else. You become a small, isolated system, trying to remain alive in a place that is actively trying to kill you. So when does Earth stop being able to help you? It happens when communication stops being immediate and starts being a 48-minute wait for a dead signal. It happens when decisions arrive hours after the critical moment has passed. It happens when rescue becomes a second mission that is 6 months away. A mission that can only launch once every 2 years. It happens when medicine becomes a countdown instead of a treatment. When invisible forces like 700 times the radiation and weakening power limits turn small failures into permanent, irreversible deaths. And the scariest part is this: you can cross that line without noticing. The ship still works. The view is still beautiful. The signal still reaches Earth, but the safety net is already gone. And from that point onward, Earth is not a place that can save you. Earth is just a bright, indifferent star behind you, getting smaller